Have you ever stopped and looked up at the sky and wondered why it's blue? It's one of those questions almost every child asks, but surprisingly few adults can answer. At first, it seems obvious. The sky is blue because, well, that's just what the sky looks like. But the more you think about it, the stranger it becomes. After all, space is completely black. The sun shines with what appears to be white light, and the air around us is completely invisible. So where exactly does that brilliant blue color come from? To answer that question, we have to begin nearly 150 million kilometers away, at the center of our solar system. Deep inside the sun, enormous nuclear reactions are constantly producing incredible amounts of energy. Some of that energy leaves the sun as tiny packets of light called photons. Every second, trillions upon trillions of these photons are launched into space, traveling at nearly 300,000 kilometers every second. For about 8 minutes, they race across the empty vacuum between the sun and Earth. What's fascinating is that during this entire journey, the light is moving through almost complete emptiness. There are no clouds, no air, and almost nothing for the light to interact with. That's why astronauts standing on the moon see a black sky, even though the sun is shining brightly above them. Space itself doesn't become bright just because light is passing through it. Light only becomes visible when it reflects off something or is scattered toward your eyes. Eventually, those photons arrive at Earth, and that's where everything changes. Although we don't normally think about it, our planet is wrapped in a giant blanket of gases called the atmosphere. In fact, we're all living at the bottom of an invisible ocean of air. This atmosphere stretches hundreds of kilometers above the Earth's surface and is made up mostly of tiny nitrogen and oxygen molecules. They're so small that we can't see them individually, but together they completely surround our planet. As sunlight enters this invisible ocean, it begins colliding with those tiny molecules. And here's where one of nature's most beautiful tricks takes place. Although sunlight looks white, it isn't actually just one color. White light is really a mixture of every color in the rainbow. Red, orange, yellow, green, blue, indigo, and violet are all traveling together inside what we simply call sunlight. Each of these colors has a different wavelength. You can think of wavelengths like ocean waves. Some are long and stretched out, while others are short and tightly packed. Red light has one of the longest wavelengths in visible light, while blue and violet have much shorter ones. Now here's the important part. Those tiny molecules in Earth's atmosphere don't treat every color equally. The shorter wavelengths, especially blue and violet, are much more likely to bounce off the molecules than the longer wavelengths like red or orange. Scientists call this phenomenon Rayleigh scattering, named after the British physicist Lord Rayleigh, who first explained it in the 19th century. Imagine shining a flashlight through a room filled with millions of tiny floating dust particles. Some of the light would continue straight ahead, but some would bounce off in every direction. Earth's atmosphere does something very similar, except instead of dust, It's billions upon billions of tiny air molecules doing the scattering. As sunlight pours into the atmosphere, blue light is scattered across the sky in every possible direction. Instead of traveling in one straight beam from the sun to the ground, it bounces around the atmosphere like countless tiny pinballs. No matter where you look during the day, some of that scattered blue light is reaching your eyes. That's why the entire sky appears blue, not just the area around the sun. What's remarkable is that the sky itself isn't actually blue. The air isn't blue either. The color exists only because of the way sunlight interacts with the atmosphere before it reaches your eyes. It's a beautiful optical effect created by physics. But if blue light is scattered so easily, another question naturally comes to mind. Violet light actually has an even shorter wavelength than blue, which means it should scatter even more. So why isn't the sky violet instead? The answer turns out to have more to do with us than with the atmosphere itself. Human eyes aren't equally sensitive to every color. We see blue much more efficiently than violet. At the same time, the sun emits slightly less violet light than blue, and some of the violet wavelengths are absorbed high in the atmosphere by a layer of ozone. Even though violet is scattered more strongly, the combination of these factors means the light that dominates our vision is blue. The result is the familiar color we've seen every day of our lives. Once you understand this, another familiar sight suddenly makes perfect sense. As the sun begins to set, the sky transforms into brilliant shades of orange, red, and gold. But the atmosphere hasn't changed. The only thing that's different is the angle of the sunlight. When the sun is high overhead, its light travels through a relatively thin layer of atmosphere before reaching your eyes. At sunset, however, the sunlight has to travel through much more air because it's approaching from near the horizon. Along this much longer journey, nearly all of the blue light gets scattered away long before the light reaches you. By the time the sunlight finally arrives, most of the shorter wavelengths have been removed, leaving behind the reds, oranges, and yellows. That's why sunsets can become so spectacular. Sometimes they're even more dramatic after volcanic eruptions or during smoky conditions. Tiny particles from ash, dust, or smoke scatter light differently than ordinary air molecules, enhancing the warm colors and creating some of the most breathtaking sunsets on Earth. Nature is constantly painting the sky using nothing more than light and tiny particles suspended in the air. The next time you step outside on a clear day, take a moment to look up. That endless blue stretching across the sky isn't a giant dome above the earth. It isn't the color of the atmosphere itself. It's the result of countless invisible molecules scattering sunlight in every direction. Every ray of blue light reaching your eyes began its journey deep inside the sun, traveled across millions of kilometers of empty space, entered Earth's atmosphere, bounced off molecules far too small to see, and finally arrived exactly where you happened to be looking. incredible to think that something so ordinary, something we've seen almost every day since we were born, is actually the result of an elegant dance between light, atoms, and the laws of physics. The sky has never really been blue on its own. It's simply telling the story of sunlight's journey through our atmosphere. And perhaps that's what makes science so fascinating. The closer we look at the ordinary, the more extraordinary it becomes.